Hello everyone and welcome to the lecture on AWS Snow Family. So this lecture will contain two products or two services under Snow Family. So it's called Snow Family or Snowball, and there are two products which are called as Snow Cone and Snowball Edge. So first I will be covering Snow Cone and then I will be covering Snowball in this particular lecture. So this lecture will contain all these topics. What is AWS Snow Cone? How AWS Snow Cone works? Use cases. AWS Snow Cone device specifications, AWS Ops Hub, which is an application to manage Snow Cone and Snowball Edge. Then I'll be covering what is Snowball Edge, a device configuration of Snowball Edge, AWS Snowball Edge features, Snowball Edge device options, Snowball Edge storage optimized specifications, device use cases, and usage workflow for Snowball Edge. So let's get started with Snow Cone first. So what is AWS Snow Cone? AWS Snow Cone is designed to be easily transportable, durable, and secure for edge computing and data transfer needs in challenging environments. Snow Cone allows data to be collected, processed, and moved to the AWS cloud, either offline by physically shipping the device or online using AWS Data Sync. Snow Cone is well suited for non-data center edge environments that may lack consistent network connectivity, space, power, and cooling. It is available in two flavors. One is Snow Cone, which is the standard Snow Cone model, which comes with two virtual CPUs, 4 GB of memory, and 8 TB of hard disk based storage, which is HDD. And second is Snow Cone SSD. The Snow Cone SSD model offers two virtual CPUs, 4 GB of memory, and 14 TB of solid state drive SSD based storage for faster data access. So with its 2 CPU and ample storage, a Snow Cone device can run edge computing workloads using Amazon EC2 instances. Snow Cone provides secure storage for data collected and processed at the edge. The compact size of Snow Cone, which is 22.7 cm into 14.8 cm into 8.2 cm, enables placement in various locations, such as next to a machinery in a factory. The lightweight of Snow Cone allows for easy portability even on a backpack. So it is at 2 kg or 4.5 pounds. The Snow Cone can be operated with a battery and connect via Wi-Fi to gather sensor data. Snow Cone device supports data transfer from on-premises Windows, Linux, and Mac OS servers and file-based applications through the Network File System NFS interface. So how AWS Snow Cone works? So first, users can request one or more Snow Cone devices through AWS Management Console, specifying their data transfer and compute performance requirements. So there are two options only. So they have to choose either SSD or HDD, hard disk drive. Then they will choose Amazon S3 buckets, data, and Amazon EC2 EMIs are automatically configured, encrypted, and pre-installed on the Snow Cone device before shipping. So actually this is part of the Snow Cone device itself. So these three information is already there. There will be some S3 buckets, some place for data placeholders, and Amazon EC2 EMIs. AWS Data Sync agent is pre-installed on the devices, which enables seamless data synchronization and transfer. Upon receiving the Snow Cone device, users connect it to their on-premises network and set up the IP addresses either manually or automatically using Dynamic Host Configuration Protocol (DHCP). AWS Ops Hub, which is a software or an application. So AWS Ops Hub for Snow Family, a graphical user interface application, must be downloaded and installed on a Windows or a Mac OS client machine, such as a laptop or a computer or desktop, to manage the Snow Cone device. So you connect this from your computer to the Snow Cone device, which is actual physical device. And after opening AWS Ops Hub and unlocking the device, users can access a dashboard that displays the device and its system matrix, allowing them to monitor their device status and performance. Then you launch instances and migrate data. So launch instances to deploy edge applications and migrate data with a few clicks. With just a few clicks in AWS Ops Hub, users can launch instances to deploy their edge applications and easily migrate their data to the Snowcon device using the intuitive interface. So basically you are transferring information from your network to the Ops Hub physical device. So it has, as I talked about, 8 terabyte and 14 terabyte of space. So you can, you will connect and start transferring data. And then you complete compute or data transfer job. So once the compute or data transfer job is completed and the device is ready to be returned, users can prepare the device for shipping. So there is an e-ink shipping label on the Snowcon device which automatically updates the return address, ensuring that the device is delivered to the correct AWS facility. When the device is shipped, users can receive tracking status updates through the various channels, including Amazon Simple Notification Service (SNS), generated text and emails, or directly from the AWS Management Console. So this is the whole procedure of how to work with AWS Snowcon, either SSD or HDD. So now let's see the use cases for Snowcon. So first is Snowcon devices can be used for edge computing applications where data is collected, processed to gain immediate insights, and then transferred online to AWS for further analysis or storage. Because the device already have some CPU and memory, and so you can process some data directly on the machine because you have the space to run EC2 also directly. Then Snowcon enables the continuous transfer of data generated by sensors or machine in factories or other edge locations directly to AWS, ensuring a seamless flow of information for real-time monitoring and analysis. So you can just keep it there and transfer because it has a Wi-Fi interface also. So with Snowcon, you can distribute various types of content such as media files, scientific data, or other relevant information from AWS storage services directly to your partners and customers, facilitating efficient content sharing and collaboration. Snowcon allows you to aggregate content by transferring media, scientific or other data from your edge locations to AWS also, thus centralizing your data and enabling further analysis, processing, or archiving in the cloud. For scenarios where your data is ready to be transferred, Snowcon provides a quick and cost-effective solution to migrate up to 8 terabyte or 14 terabyte of data to the AWS cloud by simply shipping the device back to AWS. This eliminates the need for high bandwidth internet connection. So usually, just to give a perspective, usually laptops come with 1 terabyte of space, right? So if you just think about 14 terabyte, it's like 14 terabyte, 14 laptops worth of space. And if you just compress the data even further, so you can achieve almost, you can transfer, can say 15 to 20 terabyte of data to AWS. So this will be in situations where you have low network bandwidth and you want to use this physical way of transferring data. So just think like a very big hard disk or hard drive or USB drive, and you are just ordering it, loading the data and sending it back to AWS. Then finally you will see in AWS S3 your data, 14 terabytes of data in your AWS S3 console. Snowcon devices are designed for mobile deployments and can run on a specified battery power. For light workloads with 25% CPU usage, the device can operate on battery for up to approximately 6 hours. So it can run on battery just like a laptop, and enabling data collection and processing in remote locations without access to reliable power sources. Snowcon features a Wi-Fi interface that allows you to collect data from wireless sensors, expanding the device data gathering capabilities and facilitating integration of IoT, Internet of Things devices and sensors in various environments. AWS Snowcon devices are built to withstand challenging conditions, which makes them ideal for use in remote and austere locations. They are low power, portable, lightweight, and vibration resistant, ensuring reliable operation and data protection even in harsh environments. Okay, this is the, so you can just pause the screen if you want to take a look about the device specifications. So things which I talked about, the 2 kg and the device dimensions. usage, and they have onboard EC2 AMIs and encryption. So you have NFS support, you have S3 API, but this is no. So portability, there's a battery already, 2 vCPUs, 4 GB of available memory, and the network interface, there's a data sync agent, and typical job lifetime, offline or online data transfer. So it depends how you want to use it. You can keep it for online tasks for longer periods, and max job length. So this can be edge compute or ongoing data transfer. So you can keep up to 360 days. So next is the software, AWS Ops Hub. So Ops Hub is a user-friendly tool to simplify the management of Snow Family devices. So this will be both Snow Cone as well as Snowball Edge, which I will be covering, of Snow Family devices and local AWS services. And this provides a unified interface for different device configuration. So you will interact with this particular tool to actually work with your hardware. And Ops Hub you can easily unlock. So first you will unlock the device once you receive it. Then you configure and manage both single and clustered Snow Family devices. So it can be a cluster of devices also, as well as you transfer files and launch and manage instances running on the device. So this is the single user interface through which you will be interacting with your Snowball Edge or the Snow Cone. Then this supports the management of both storage optimized and compute optimized Snow device types. So this I will be covering. So there are two types within Snowball. So it lets you interact with both the devices. And the intuitive interface of Ops Hub enables quick data migration to AWS Cloud and efficient deployment of edge computing applications. So you use this to transfer data to the Snow Family devices. And Ops Hub integrates with AWS Systems Manager. So there is a Systems Manager service which have direct integration with Ops Hub, and this lets you automate operational tasks. It provides a dashboard for monitoring key metrics and allows you to manage EC2 compatible instances with just a few clicks. It is designed to be accessible for users with varying technical expertise, and AWS Ops Hubs enable a wider range of users to manage their Snow Family devices. So getting started is easy. You just simply download, install and launch. So you can actually just go ahead and install if you want on your regular computer as well, but without the hardware you cannot do much. And as soon as you start, after installing, you can just start transferring to your Snow device. Okay, next is Snowball Edge. So Snowball Edge, what is Snowball Edge? AWS Snowball Edge device comes with built-in storage and computing capabilities for specific AWS functions, enabling local data processing and edge computing. So it's similar to Snow Cone only. And these devices can handle data processing locally and execute edge computing workloads in addition to their data transfer capabilities. Snowball Edge enables data transfer between your local environment and AWS Cloud or vice versa, and provides a seamless way to move data. Each Snowball Edge device can transport data at speeds faster than the internet by physically shipping the data loaded devices through a regional carrier, and this makes it an efficient option for large scale data transfer. So I'll talk about the storage. So it is very optimal for very high amount of large scale data transfer. The Snowball Edge appliances are built to be rugged and durable, equipped with e-ink. So there is a electronic ink shipping labels for easy identification and tracking during transport, ensuring safety and security of your data. So first, there are types of device configuration. So there are three types. So first is storage optimized for data heavy tasks. So one of the three available configuration for Snowball Edge devices, optimized for storage intensive tasks and large scale data transfer, thus making it ideal for data heavy workload. So if your primary needs is just to transfer a very huge amount of data from your local premises to AWS Cloud, you go for storage optimized. Then you have compute optimized for intensive processing. So another configuration option for Snowball Edge, designed for compute heavy workloads and applications that require high processing power, enabling more intensive data processing tasks. So if you want to do some processing also while keeping it on premises or during the transfer, you can go for compute optimized. So you can run computation tasks or analytics at the same time. Third one is compute optimized with GPU for graphical processing. The third configuration option, which includes an onboard GPU for accelerated computing and graphic intensive tasks, perfect for workloads that require high graphical processing power. And specific feature and capabilities for each configuration. So when referring to Snowball Edge devices in general, it includes all three configuration options. However, when specific information applies only to one or more configuration, such as the presence of a GPU in the compute optimized with GPU option, it will be explicitly mentioned to highlight the unique capabilities. So I'll be covering that. So AWS Snowball Edge features. So large amounts of storage capacity for compute functionality for devices. So network adapters with transfer speeds up to 100 gigabit per second. So it's very high. So it's like a regular network only. Encryption is enforced, protecting your data at rest and in physical transit. You can import or export data between your local environment and Amazon S3 and physically transport the data with one or more devices without using the internet. So not only you can import into S3 or cloud, you can, if you want to export back very huge amount of data, that also can be used. Snowball Edge devices are their own rugged box. The built-in e-ink display changes to show your shipping label when the device is ready to ship. So that this will be dynamic label on the device itself. Snowball Edge device comes with an onboard LCD display that can be used to manage network connections and get service status information. You can cluster Snowball Edge devices for local storage and compute jobs to achieve data durability across 3 to 16 devices and locally grow or shrink storage on demand. So you can cluster up to 16 devices. You can use Amazon Elastic Kubernetes Service EKS anywhere on Snowball Edge devices for Kubernetes workloads. Snowball Edge devices have Amazon S3 and Amazon EC2 compatible endpoints available, enabling programmatic use cases. Snowball Edge devices support the new SB1, SBE-C and SBE-G instance types, which you can use to run compute instances on the devices using Amazon Machine Images, AMIs. So these are some instance types which you can run directly on the Snowball Edge. And Snowball Edge supports these data transfer protocols for data migration: NFS v3, NFS v4, NFS v4.1, and Amazon S3 over HTTP or HTTPS via API compatible with AWS CLI version 116.14 and earlier. Okay, now this is a quick table. If you want to pause, you can take a look. So as I talked about Snowball Edge device options, you have storage optimized, and then you have edge storage optimized up to 210 terabyte. So this one is less, like it's 80 terabyte and then 1 terabyte SATA and 210 terabyte NVMe. And the network interfaces SSD. What are the options available between these two? Security guard and usable memory. So this is the RAM. And then you have storage optimized with EC2 or compute functionality. And then you have Snowball Edge compute optimized with AMD EPYC. So this is one more model or one more variation, and it has the highest usable memory of 416 GB of RAM and this much of solid state drive SSD storage, 28 terabyte, right? This one is 210 terabyte because it's more for storage, and this is for computing. So less storage but higher usable memory. Now this both has same, but because this has pretty much all the maximum capabilities. You have 104 vCPUs, so maximum. So this is storage optimized 210, and then if you have finally compute optimized with AMD EPYC, and this one has 52 vCPUs and slightly different configuration, 208 GB usable memory and GPU. So this one is GPU. This one supports GPU. So only one has this particular option, and 7.68 terabyte, and usable hard disk drive is 39.5. So you can just pause the screen if you want to take a look. And now specifically if you want to go, so this is Snowball Edge storage optimized. This is the first option. So if you want to take a look, what are the different, so now it's earlier was the hardware, now it's the what is the physical specification. So its power is 304 watts, voltage is this much, frequency is this much, and network interfaces I have already covered. about cables, thermal requirements, decibel output, all those things. And same the weight. So this is you can see this is 22.54 kilogram, 49.7 pounds. So this is much heavier compared to snow cone. So snow cone was coming around 2 kilogram, and this is coming up to 22.54 kilogram. And dimensions are much heavier. You can see it's like a proper, like a suitcase or a briefcase kind of dimensions. And you can see the environment specification: vibration, shock, altitude, and temperature range. And device use cases. So Snowball Edge is the, because this has a superset of all snow cone. So it supports all the feature: import, export from S3, durable local storage, local compute with AWS Lambda, local compute instances, durable Amazon S3 storage in a cluster of devices, use with AWS IoT Greengrass, and transfer files to NFS with a GUI, and GPU workloads. So it supports all things. And this snow cone, only the few things which it doesn't support is the export from S3 and durable local storage. And GPU workloads it cannot support because it's a lightweight device. And the usage workflow for Snowball Edge. So first you create the job. Each job is created in the Snow Family management console or programmatically through the job management API. So the status for a job can be tracked in the console or through the API. So you just log into AWS management console and use the Snow Family service and create a job. Then a device is prepared for a job, and the AWS prepare an AWS Edge device for this job, and status of job will be now preparing Snowball. Then a device is shipped to you by your region's carrier. The carrier takes over from here, and the status of your job is now in transit to you. You can find your tracking number and a link to this tracking website on the console or with the job management API. Then fourth, you receive the device. A few days later, your region's carrier delivers the Snowball Edge device to the address that you have provided when you created the job in the management console, and the status of job changes to delivered to you. When it arrives to you, you will notice that it did not arrive in a box because the device is its own shipping container. And then you get your credentials and download the Snowball Edge client. Then after that, you get ready to start transferring data by getting your credentials, your job manifest, and the manifest unlock code, then downloading the Snowball Edge client. Then you position the hardware. You move the device into your data center and open it following the instructions on the case. You connect the device to power and your local network. Seventh is the power on the device, and you power on the device by pressing the power button above the LCD display. You wait few minutes, then ready screen appears. You get the IP address for the device, and the LCD display has a correction tab on it. Tap this tab and get the IP address for Snowball Edge device. So use the Snowball Edge client to unlock the device. So when you use the Snowball Edge client to unlock the Edge device, you enter the IP address of the device, the path to your manifest, and the unlock code. Snowball Edge client decrypts a manifest and uses that to authenticate your access to the device. Then finally, the device is up and running. You can use it to transfer data with Amazon S3 adapter or the network file system mount point, or for local compute and storage with Amazon S3 compatible storage on Snow Family devices. After you are done with the device in your on-premises location, you press the power button above the LCD display. This can take up to 20 seconds. Also, for the device to power off, you unplug the device and its power cables into the cable nook on top of the device. Shut all three of the device doors, and device is now ready to be returned. Your region's carrier returns the device to the AWS. So when the carrier has the AWS Snowball Edge device, the status for the job becomes in transit to AWS. And that's all. Thanks for watching.